Okay, guys, so today we're going to get into circles and ellipses. These are forms of conic sections. That's why this section is called conic sections. The reason it gets the name conic sections is because it has to deal with cones. And so if you look at this picture, you'll notice the cone here and the cone here. And depending on how they cut the cone with the plane, you will see a different shape. For instance, they have a parabola. If they cut it slanted on one end, if they cut it horizontally, you can get different size of circles. If they cut it slanted to where it goes through both sides, you can get a ellipse. And then finally, you can get a hyperbola if it's cut vertically on both ends. Just to note, parabolas are important to conics, although we've spent quite a bit of time on parabolas already, although we didn't do sideways ones, so I'm actually not going to cover it this time through. Plus, we have a lot of circumstances we're under right now, so I just want to try to get through circles, ellipses, and hyperbolas for you guys, and we'll see what we can do with this. So, just so you know, there are standard forms for both circles and ellipses and hyperbolas. Ellipses can be horizontally or vertically oriented, and you must look at the numbers under X and Y to determine which orientation it has. We're going to work on ellipses and circles, but first we're going to work on circles in this video. So, if you have a circle, it has a center, and at the center it has a radius from that center. At every point outside of that circle will be the same distance from the radius. Well, I'm sorry, the same distance from the center. And that, in this case, we're going to say that that radius is 2. So the first thing we're going to do is we're going to graph the center, which is at -1, 0, so that would be right here. Okay. All right, so we've got the center of this circle graphed. Now, the radius is 2. So we know that every point is 2 away from that. So we're going to go 2 to the right, 1, 2. There's a point here. There's going to be a point to the top, 1, 2. We go 2 left, 1, 2. And we go 2 down, 1, 2. Okay. So now that we've got all these points, we can attempt to draw our circle. And if we do it close enough, let me do this one more time, try to get this perfect, get this a little bit better. Oh, let's do it one more time. There we go, that's a little better. Then we will have a circle graphed out with a center of -1, 0, and a radius of 2. And so we're just going to assume that all these points out here are 2 away from the center as well. They should be, if this is in fact a circle. Obviously, we're using software to make it more round, so it looks pretty good. I mean, it's done a fairly good job with it. And with that being said, then we have our circle drawn. So next, I want to look at some more things. So I'm going to go ahead and fix this circle. Oh, that's not good. I'm going to do my best to keep it nice for you. We don't want the circle anymore, though. Let me see if I can get rid of it. So let me see. Delete. Nope, didn't delete it. Ah, there we go. Much better. Okay, so now we'll look at the next part of these types of problems that you're going to encounter. So we've got the following. We've got the standard form. And the standard form comes in the form x minus h plus squared plus y minus k squared equals r squared, where h and k are the center and r is the radius. Now, before I told you that h was the only liar. However, in conics, k can also lie to you. In circles, ellipses, and ellipses, it will lie to you. So we need to keep that in mind. I don't remember. I think it lies in hyperbolas as well, but we'll get there when we get there. So with that being said, if we look at this equation, let's identify h, k, and and r and see if we can't graph this circle. So in this case, we have x minus h. Well, there's nothing being subtracted from x, so in this case, h must equal 0. Okay, then k is positive 2. Oops, that should be plus. K is positive 2, and so that means, or I'm sorry, k is, if we look here, we notice that this is positive 2, so the k is lying in this case, so that's negative 2. And then r squared is equal to 1, so if we take the square root, r must equal 1. Okay. Obviously, you just assume that's r squared, and then you go ahead and solve it from there. So with that being said, we know that we have a center at 0, negative 2, and a radius of 1. So we can go and graph that. We go down to negative 2, 1, 2, and then we go a radius of 1. So 1 over, 1 up, 1 down, 1 left and right, 1 for each, and then we attempt to draw our circle. And we get the following circle, and so this would be the graph of x squared plus y plus 2 squared is equal to 1. Okay, so we would have graphed that circle. Now, the next one, we'll do one more like this, and then we'll do a more challenging one. So we are going to do the following one. Drag this up here so that it's in range of our stuff. We'll get rid of all this. We don't need this. Then we will get rid of this circle. Bye-bye. Bye-bye. And then we'll go ahead and erase these. H here. Sorry, I'm working without talking. So obviously, if we look here, h and k, h is 1. It's the opposite of negative 1, and then k is negative 2. And r squared is equal to 9. Square root r is equal to 3. Okay, so we've got 1, negative 2 as our center. Oops. Doesn't like that, center. And then we've got our radius at 3. So we go to 1 and negative 2. So 1, negative 2, there's the center. Then we're going to count 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Always to up, down, left, and right. 1, 2, and 3. Then we draw our circle the best we can. And there would be our graph of this equation. Okay. Now, we have one more example. These are the more challenging ones. These are the types that you're likely to see on a test. So they don't always have to give you it in standard form. For instance, they could give you it in the following way. Give me one moment. We've got the following. Okay, we've got x squared plus y squared plus 6x minus 4y minus 12. Now you might be saying to yourself, how in the heck are we going to get a standard equation out of that? Well, remember when we did quadratics, we did completing the square. We're actually going to do that here right now 2 times. We're going to combine like terms, and then we're going to get the equation of a circle. So here we go. First step, you're going to line up your x's with x's. Put them next to each other. We're going to add something. Subtract something. Okay. And then we have our parentheses and another set of parentheses. I'm only going to put that because you'll want that if you're doing an ellipse and there's a coefficient, lead coefficient in the front. Okay. Then we're going to line up our y's. So we have plus parenthesis, parenthesis, y squared minus 4y. I'm going to draw a triangle. Oops. Let's see if we can get it to make a nice one. Plus a triangle. minus a triangle, and then is equal to negative 12. Okay, so far so good. Now we're going to complete the square on both of these. So for the square, this one, the x values, we have the square is equal to, we've got, remember it's b over 2 squared, which is going to be 6 over 2 squared, which is equal to 3 squared, which is equal to 9. So we're going to add and subtract 9 in both cases. Then for the triangle, we have negative 4. So we have negative 4 over 2 squared, which is negative 2 squared, which is 4. So this is 4, and this is 4. Okay. Now, we are going to, the nice thing is I can just move this because I don't want this in the way. Let me move that, give me one sec. Okay, that's out of the way now. There we go. So now, this thing factors nicely. Remember, we have this positive 3, so this is just x plus 3 squared minus 9. This factors nicely. This is going to be plus y minus 2 squared. Notice that I went up here and filled that in from there to here. And then minus 4 is equal to negative 12. Okay, so we combine like terms. This is x plus 3 squared minus plus y minus 2 squared. We have a minus 9 and a minus 4 on this side. That's minus 13 is negative 12. And that's, let's add the 13 to the other side. X plus 3 squared plus y minus 2 squared is equal to 1. So in this case, h is negative 3, k is 2, that's our center. We have radius squared is equal to 1, which means r is equal to 1. So negative 3, 2 with radius 1, we will graph that. We are going to go negative 3, 2, 1, 2, 3, down, up 2, 1, 2. And then we're going to use our radius of 1. So we've got 1, 1, 1, and 1, and we draw our circle. That didn't look so nice. Let's do it again. Whoop. We draw our circle. Something like the following. Uh-oh. I wonder why ink to shape stopped working. Let's try it again. One more time. There we go. And we have our circle, and that would be the graph. This equation would give this equation, which obviously gets graphed as this circle. Thank you.